When graphing an absolute value function, the first thing you should do is start by sketching the original graph. So in the equation y equals the absolute value of 2x minus 6, my original equation is going to be y equals 2x minus 6. Now we should remember from grade 10 that the general form of a linear equation y equals mx plus b, our constant is going to be our y-intercept, and our coefficient in front of the x is going to be our slope. So I'm going to start my graph at -6, because that's my y-intercept. Because I know I've got a slope of 2, a rise of 2, and a run of 1, means my graph is going to go up in this fashion. So up 2 over 1, and I can go as far as I want on this graph. Now I'm going to connect my graph with a nice straight line. And I've got a graph of my original function. But an absolute value function means any of these values down here in the negative side have to be moved to the positive side. So this point right here has a y value of -2. I need to reflect it, so now it's got a y value of +2, because the absolute value is going to move the negative into the positive. This one's at -4, I'm going to move it to +4. This one's at -6. I'm going to move it to +6, and then I'm going to connect my line with the line at 0, because at x equals 0, or y equals 0, the line's going to change direction. Now my last step, I need to get rid of everything in the negative, so I'm just going to erase that. And there's what my absolute value graph looks like. Now I've been asked to determine the x and y intercepts and the domain and range. My x-intercept, I can read off my graph, and that's the location where my graph goes through 0. So in this case, it's at +3. So my x-intercept is the point 3, 0. My y-intercept is where my graph goes through the y-axis. So that's going to be this point right here. In this point, it's going to be 0, 6. When finding the domain, we're looking for all of the possible values of x. And since we know in this graph it's a linear graph that's going on forever in both directions, the domain is going to be x's all round numbers. Now my range is all of the possible values of y. So you can see in this case that my graph goes down to 0, but then at 0 it turns around and goes back up. And because we can't have any absolute values less than 0, my range is going to be y is greater than or equal to 0. A quadratic function is drawn in a similar way. Here's a quadratic function that we've got that's written in vertex form. So we can figure out in this case our vertex is going to be -1, -2. Because our p-value is -1 and our q-value is going to be -2. So I'm going to start at -1, -2, and that's going to be my vertex. Now my original pattern for drawing a parabola was over 1 up 1, over 2 up 4, over 3 up 9 with a pattern of squares. But because I've got a 2 here, I'm going to need to double all those values. So I'm going to go over 1 up 2, I'm going to go over 2 up 8, and then I'm going to be off my screen. So over 1 up 2, over 2 up 8, and there's a sketch of my original parabola. Because it's the absolute value, similarly to the linear one, I'm going to take any of the values that are less than 0 or on the negative side, and I'm going to reflect them to the positive side. So I do have a point at -2 on the y. I'm going to move it to +2. When I connect my dots, it looks like that, and I'm going to erase my original function less than 0. So this W shape is going to be the shape of a quadratic absolute value function. Now I need to determine the x, y intercepts and the domain and range. So my x-intercepts, and I have 2 here, I'm going to have one at -2 and 0. My y-intercept, I'm going to have one at 0. My domain, just like a regular parabola, x goes on forever in both directions, so my domain is all around numbers. And my range, which is going to be similar to a lot of absolute value functions, my graph will go down to 0. It goes back up for a bit, goes back down to 0, but it never goes lower than 0. So my y is greater than or equal to 0.